All right, we're trying this again. I recorded this last night, but didn't have my volume turned up enough, so the audio is very quiet. And, as a benefit, now there's way more implemented than there was yesterday. So, as you can see on the screen here, it has come time to implement Volatus in Rust. So I have started porting over the configuration library functionality, and I have got this nice juicy bit of code here. My first ever Rust library. So this is generic. It's not super generic because it's not an abstract data type, but a data structure in memory that can support the tagged unions, which are enums in Rust, for different data types. So a single value can identify and store different values. Then there's some that do technically hold values from the structure of the configuration, but they just correspond to it having children. So this has been an interesting journey. It's been simultaneously more frustrating and way less frustrating than I was expecting up front. I have not been fighting the borrow checker very much after the first day. As soon as I broke myself of my object-oriented habits and started to embrace Rust's preferred ways of doing things, it turns out my LabVIEW experience in doing data structures actually translates pretty directly. So in this data structure, I'm storing just a flat array, a vector, resizable array, of the configuration elements. And then the elements wrap those values and some identifying information and links to the children and parent and all that. So this is in fact a tree structure, even though internally it is stored as a vector, just a flat array. And then for some optimization, if you remove elements, it keeps track of those vacant spaces. Because if we look at element, what we're actually keeping track of is just the index of the links. So whenever you work with elements in this library, you're not working with an element directly. You're not getting a reference to it. Managing lifetimes of references and borrows and pointers and boxes and RCs and ref cells and all that fun stuff that you get introduced to in Rust. Kind of a pain in the butt. So this just does not do that. So it's not while it does have perfect like reference and memory safety, your element handles can be an index to something that it doesn't necessarily point to anymore. So it feels like cheating. It's kind of working around the Rust borrow checker by using identifying types that are perfectly safe memory-wise, but definitely not necessarily functionality-wise. But that's okay. I'm okay with that. So you have the element handle, which just wraps a private index into the vector of elements. And then with that element handle, there's a couple of convenience. Well, right now there's one convenience method. I've been getting rid of some just so there's a more consistent interaction. But then with those handles, you can do stuff. So let's look for all these public ones like set meta values. So you pass in the element handle. It uses that to get the internal element, either mutable or immutable, and then reads from it or updates parts of that element. So we can remove elements, get the length, so the number of elements that are stored in the configuration tree, what the element's name is. So you don't do anything with the element handle directly 99% of the time. The only thing that is implemented on the element itself, if I can figure out where I'm looking here, or the element handle, is new child, because then it's really convenient for the parent of the new child to pass itself in as the parent when a new element is getting created. So all of the interaction is done through that manager class that manages the vector of elements. So I'm expecting that I'm going to run into difficulty when I start trying to make this thread safe, but it is so far working very well. The other very surprising thing with Rust is the built-in support for tests means I have a whole bunch of tests already. So these live adjacent to the code. They only get compiled into the executable when you're running the test. So you do cargo test. And this does a build with all of the tests embedded in the executable and runs them, collects them, does all of that extra stuff that it inserts in to do the testing. So that is super convenient. Previously I was just passing the index itself in and out of the manager effectively. But I decided I wanted a little bit more protection around that. So I then created this element handle struct to hide the index. So I have the ability to change that. And once I got through and updated all of the implementation in the manager and some support methods, none of the tests changed. So thanks to the type inferencing, so anytime it's creating elements, previously it was an element index, now it's an element handle, but Rust inferences the type for you. It was the same exact pattern of options and results and unwrapping and all the fun conditional stuff you do for well, in this case, these are tests, so I'm not doing error handling per se, but to accommodate for the fact that there might be failures in these operations. So the code pattern, the usage stayed exactly the same. I changed none of the test code. And then once I had the element handle, which let me implement more methods, I implemented more tests to further test the functionality. So this has been pretty exciting. Pretty much the next thing now, since this is feature complete for the storage of the data, the next thing I'm going to do is work on the serialization and deserialization logic to translate stuff like YAML or JSON or a SQLite database into this in-memory data structure, which then supports all of the same kind of identification, element identification, and traversals that the LabVIEW implementation did and that the Python implementation does. And the more I play with this, the cleaner it gets. There's some stuff that started out twice as long as it is now, and then just over the last couple of days as I have been figuring things out as I go, I've been able to get things implemented much more concisely, which has become my litmus test. I'm already starting to get a heuristic built in on if I'm making my work harder than it should be based on how much code I have to write. When you stick to the Rust basics, it seems like it's very, very concise. So lots of very short wrapper methods and conditionals and just good and concise. Even down here in some of these tests when we're wanting to do some checks, using the iterator patterns and builder patterns for iterators and all that fun stuff is nice and concise. If we look at the method that looks up descendants, whoa, come on, VS Code. Should probably use the outline. Figure out where I'm going here. Descendants. This is not a very big method at all. So to dive into this for an example, so there's the element lookup struct, which can keep track of an array of a vector of the criteria we're looking for in elements that are descendants of a starting element. And this is just a basic breadth first traversal. So we've got a double-ended queue, which is our search frontier. Initialize it with all of the children of the starting element. And then as long as there's elements to investigate, check to see if it matches. If it does, add it to the found vector. If it doesn't match, or we're going to continue looking past matches, and this is just a quirk in some of the ways I've implemented some of the configuration for some components of Volatus, is that you can, for instance, have channels nested inside of channel objects, which has been a convenient way to have like some kind of entity that is commandable, such as some automation feature that you can turn on or off, but then that feature that you can turn on or off has parameters that you can send commands to update. So there's different times you'd want to look past once you find a match down a tree path, or if you just want to stop as soon as you find it. Like, groups cannot be nested inside a group. So if you're looking for groups, which are collections of channels, there's no reason to look for further groups past the group you just found. So there's different situations like that where that can help. But so yeah, if that node didn't match, or we're looking past matches anyway, we take all of the current node element we're looking at's children and put them on the frontier queue to continue searching. So using this arena style memory management, where we're just keeping track of indexes into the vector, has turned out to make a lot of this way more straightforward than it would be if I was trying to use references all over the place, and shared ownership or internal mutability, all of the keywords from the Rust programming book that I've read about, and I'm trying to keep my distance until I have to, which seems to be the prevailing advice. A lot of those features get overused by newbies, so I'm trying to stick to patterns that are much more similar to LabVIEW's LabVIEW's by value by default implementation, which fits Rust very well. So yeah, up next is serialization, deserialization. Then I will start to implement the networking capabilities for Volatus in this Rust port. And then after that, before that, I need to do the threading and module pattern, which might throw a wrench in this entire config library design. I'm not sure how much of a pain in the butt it is going to be to access this config across multiple threads. So that might warrant some changes. It is a decently big class, or struct, but fortunately there's not very much here. So hopefully once I get to that point, it's not too painful. So yeah, so once the threading and the module pattern is defined for Volatus and Rust, then I will use that to implement the networking communications capabilities and the kind of the core of the application. And then I'm going to start with the GUI using the Bevy game/graphics engine that is available for Rust, and just take it off from there. There is already a DACMX crate available for Rust that McNally has published, and there is an NIFPGA. There's a couple of people that have published those crates. None of them do stuff like read the actual LVBitX file to see the signatures or the addresses for the elements. They kind of expect you to look them up yourself, which surely we can be capable of parsing the LabVIEW-bitx file in Rust. It's just XML, and then alleviate ourselves from manually transcoding that information into our programs as hard-coded values. Because boy howdy, that's not great. There's already a configuration file. It's the bit file itself. So let's use that. So yeah, so the journey has started. Moving away from LabVIEW, moving into Rust. The Python framework has gotten a lot of updates lately and is getting close to feature parity with the LabVIEW implementation, as far as the core like module design, networking, configuration handling, all of that. It's not feature parity in all of the modules that have been implemented in LabVIEW so far, but it certainly would not be difficult to do that, other than Python being single-threaded by default, which incurs some performance limitations that I'm already running into trying to push a lot of data out of an FPGA. But yeah, so curious if anybody has any questions. If this looks like an interesting project. If you're unfamiliar with Volatus, this is going to be a distributed data acquisition and controls application framework. It's kind of batteries included, very opinionated about configuration, although not necessarily the configuration format. Eventually, this will handle many serialization formats for config storage, but very opinionated about the networking, the configuration, data structure, stuff like that, so that it can not have too many layers and conversions between a whole bunch of different packages that weren't originally designed to work together. So this is going to be the full framework, full application framework for distributed controls. So GUIs for test cells where there can be combinations of manual operations of valves and analog outputs and all that fun stuff, paired with sequencing engines that can automate behaviors. There'll be time-based sequencing, state-based sequencing, all sorts of fun stuff like that. And then at this point, a handful of features could be implemented in Python. You could do your automations as Python scripts. You could do your calculations as Python scripts, which has been made really easy recently. But really excited where this is going.